Close your eyes, and let's drift back in time, back through the centuries, through the millennia, past the rise of humanity and beyond, to a world that existed long before us. Our story begins approximately 230 million years ago, during a period called the Triassic. The Earth looked nothing like it does today. All the continents were joined together in one massive supercontinent called Pangaea. Imagine standing in the center of this enormous landmass, able to walk from what would one day be Antarctica to what would become North America, without ever crossing an ocean. The climate was warm and dry across much of Pangaea, and it was in this ancient world that the first dinosaurs began to appear. These earliest dinosaurs were quite small, nothing like the giants they would eventually become. Most were no larger than a modern dog, walking on two legs, swift and agile as they navigated through forests of primitive conifers and ferns. The very name dinosaur wouldn't be coined until 1842, when British scientist Sir Richard Owen examined fossilized bones and realized they belonged to a distinct group of ancient reptiles. He combined two Greek words, deinos, meaning terrible or fearfully great, and sauros, meaning lizard. And so the terrible lizards received their name, though we now know they weren't actually lizards at all. For nearly 165 million years, dinosaurs would rule the Earth. To put that in perspective, modern humans have only existed for about 300,000 years. The dinosaurs' reign was more than 500 times longer than our entire existence as a species. They witnessed the continents slowly drift apart, they adapted to changing climates, and they evolved into an extraordinary diversity of forms. During the late Triassic period, around 225 million years ago, one of the earliest known dinosaurs walked the Earth. Herrerasaurus was a carnivore, roughly the size of a large dog, with sharp teeth and powerful hind legs. It lived in what is now Argentina, hunting smaller reptiles through forests where the only sounds were the rustling of primitive plants and the distant calls of early reptiles. As we move through these early chapters of dinosaur history, picture the world transforming slowly around these creatures. The Triassic period gave way to the Jurassic, beginning around 201 million years ago. The climate became more humid, encouraging lush vegetation to spread across the separating continents. Ferns, cycads, and ginkgo trees created dense forests, and the dinosaurs began to truly flourish and diversify. It was during the Jurassic period that dinosaurs split into two major groups, distinguished by the structure of their hip bones. The Saurischia, or lizard-hip dinosaurs, included the enormous long-necked sauropods and the fierce theropods like Tyrannosaurus rex. The Ornithischia, or bird-hip dinosaurs, were all herbivores and included creatures like Stegosaurus and Triceratops. Interestingly, despite the names, it was the lizard-hip dinosaurs that would eventually give rise to birds. By the middle of the Jurassic period, around 170 million years ago, the first giant sauropods appeared. These magnificent creatures would become the largest land animals ever to walk the Earth, with some species reaching lengths of over 100 feet and weights exceeding 70 tons. Imagine these gentle giants moving slowly through ancient forests, their long necks reaching high into the canopy to strip leaves from the tallest trees, while beneath their feet, the ground trembled softly with each step. Let these ancient creatures walk through your mind as you drift towards sleep, their world vast and peaceful, unchanged for millions upon millions of years. As you relax deeper, let's continue our journey through the age of dinosaurs, where time moves slowly, like the gentle sway of ancient ferns in a prehistoric breeze. The sauropods, those magnificent giants we just encountered, had a remarkable adaptation that helped support their enormous size. Their bones were not solid like ours, but instead contained hollow spaces filled with air, much like the bones of modern birds. These air sacs made their skeletons much lighter than they would have been otherwise, allowing them to grow to such incredible sizes without collapsing under their own weight. Picture these gentle titans, their bodies a marvel of natural engineering, breathing slowly as they move through a world built on a scale we can barely imagine. Now, let's turn our attention to a creature that has captured human imagination like few others. Tyrannosaurus rex, the tyrant lizard king, lived much later in dinosaur history, during the very end of the Cretaceous period, around 68 to 66 million years ago. Despite its fearsome reputation, T-Rex didn't exist for most of dinosaur history. In fact, Stegosaurus, which lived during the Jurassic period, was already extinct for about 80 million years before the first T-Rex walked the Earth. The time that separates Stegosaurus from T-Rex is greater than the time that separates T-Rex from us. The T-Rex itself was truly impressive. Adults could reach up to 40 feet in length and stand about 12 feet tall at the hips. But perhaps most remarkable were their teeth, some measuring over 12 inches long, including the root. These weren't thin, blade-like teeth, but thick, powerful bones crushers, capable of generating a bite force of up to 12,800 pounds. This allowed T-Rex to crunch through the bones of its prey, something few other predators could do. But not all dinosaurs were enormous. Let us drift now to the other end of the size spectrum, where tiny dinosaurs scurried through the underbrush. The smallest dinosaur we've discovered is Microraptor, which lived about 120 million years ago in what is now China. This little creature weighed only about 2 pounds and measured roughly the size of a modern crow. Microraptor had an extraordinary feature: it possessed 4 wings, with long feathers on both its front and hind limbs, allowing it to glide between trees in the dense forests of the early Cretaceous. Speaking of feathers, this brings us to one of the most profound revelations of modern paleontology. Many dinosaurs, particularly the theropods, the group that includes T-Rex and Velociraptor, were covered in feathers. These weren't always the flight feathers we see on modern birds, but often a downy coating that provided insulation. Imagine a young Tyrannosaurus rex, fuzzy with a coat of primitive feathers, looking far less reptilian than we once believed. Fossils discovered in China over the past few decades have preserved these feathers in exquisite detail, forever changing how we picture these ancient creatures. And here's a thought to ponder as you sink deeper into relaxation: birds are dinosaurs. Not descendants of dinosaurs, but actual living dinosaurs. When the Great Extinction Event occurred 66 million years ago, wiping out the non-avian dinosaurs, one branch of the dinosaur family tree survived: the birds. Every sparrow, every eagle, every penguin is a direct descendant of theropod dinosaurs. In a very real sense, dinosaurs never truly went extinct. They evolved, adapted, and continue to soar through our skies today. The diversity of dinosaurs was staggering. They ranged from the enormous Argentinosaurus, which may have weighed up to 100 tons, as much as 15 elephants, to the tiny Microraptor we mentioned earlier. Some had elaborate crests and horns, others had armor plating or massive clubs on their tails. there were dinosaurs adapted for nearly every ecological niche: swimming dinosaurs like Spinosaurus, burrowing dinosaurs like Orictodromeus, and even dinosaurs that could glide through the air. One of the most peculiar dinosaurs was Therizinosaurus, which lived around 70 million years ago. This strange creature had the longest claws of any known animal, with each claw measuring up to 3 feet in length. Despite these fearsome weapons, Therizinosaurus was actually a herbivore, likely using its enormous claws to pull down branches and strip leaves. It walked upright on 2 legs, had a pot belly, and a long neck. Imagine a cross between a sloth and an ostrich, but the size of a large elephant, moving slowly through late Cretaceous forests. As these images drift through your consciousness, feel yourself sinking deeper, traveling further back through time, where the pace of life was measured not in years but in epochs, not in generations but in millions of years of gradual change. Breathe slowly and deeply as we continue our peaceful journey through prehistoric time, where each moment stretches across millennia. Let's turn our attention now to one of the most recognizable dinosaurs, with its distinctive plates rising from its back. Stegosaurus roamed North America during the late Jurassic period, around 155 to 150 million years ago. Those iconic plates along its spine, some reaching up to 2 feet tall, have puzzled scientists for generations. Despite appearing as armor, they were actually quite fragile, filled with blood vessels. Most paleontologists now believe these plates served as a temperature regulation system, allowing Stegosaurus to warm up or cool down by controlling blood flow through them, much like a natural radiator. The animal would position itself to catch the sun's rays when cold, or face away to release heat when warm. Here's something that might surprise you as you drift towards sleep: dinosaurs had relatively small brains compared to their body size. Stegosaurus, despite being the size of a bus, had a brain no larger than a dog's, about the size of a walnut. For many years, people believed there was a second brain in its hip area to help control its back legs and tail, but this has been disproven. Stegosaurus managed perfectly well with its small brain, a reminder that intelligence takes many forms, and survival requires more than just brain size. Now, let yourself float forward in time to the Cretaceous period, around 110 million years ago, where herds of duck-billed dinosaurs gathered near ancient rivers and loch shores. These were the hadrosaurs, sometimes called the cows of the Cretaceous because they were so abundant and filled the same ecological role as large grazing mammals do today. Some hadrosaurs, like Parasaurolophus, had extraordinary hollow crests on their heads that could be up to 6 feet long. These crests function as resonating chambers, allowing the dinosaurs to produce deep, haunting calls that could travel for miles across the ancient landscape. Imagine the sound, low, trumpet-like calls echoing through misty valleys as herds communicated across vast distances. The hadrosaurs had another remarkable feature: their teeth. While many dinosaurs had simple, replaceable teeth, hadrosaurs possessed sophisticated dental batteries containing hundreds of tiny teeth packed together. Throughout their lives, they could have up to 1,400 teeth in their mouths at any given time, with new teeth constantly growing to replace worn ones. These dental batteries allowed them to grind tough plant material with remarkable efficiency, much like a living food processor. Let's drift now to the southern continents, to what was once Gondwana. In what is now Argentina, around 95 million years ago, lived one of the strangest predators ever to exist. Carnotaurus, whose name means meat-eating bull, had a body unlike any other large predator. It possessed two distinctive horns above its eyes, giving it a demonic appearance. Its arms were even more reduced than those of T-Rex, tiny, almost vestigial limbs that seemed to have been nearly useless. But its most unusual feature was its skull, short, deep, and powerful, built for head-butting. Scientists believe Carnotaurus may have used its horned head in combat with rivals, charging and striking like a prehistoric ram. As you relax even further, consider this: dinosaur eggs were surprisingly small compared to the adults. Even the largest dinosaurs, those weighing many tons, emerged from eggs no bigger than a basketball. This is because eggshells need to be porous enough for the embryo inside to breathe, and if an egg became too large, the shell would either be too thick for oxygen to pass through, or too thin to support the egg's weight. So every massive sauropod began life as a tiny hatchling, growing from perhaps 10 pounds to 70 tons or more, an increase of about 14,000 times their birth weight. Some dinosaurs were devoted parents. Maiasaura, whose name beautifully means good mother lizard, lived around 75 million years ago in what is now Montana. Fossil evidence shows that Maiasaura built nests in colonies, returning to the same nesting grounds year after year. They would arrange vegetation in bowl-shaped nests about 6 feet across, and unlike many reptiles that abandon their eggs, Maiasaura parents stayed with their young. Fossils of juveniles found in nests suggest the hatchlings remained in the nest while the parents brought them food, much like birds do today, a touching glimpse of parental care stretching back millions of years. Finally, as you settle deeper into tranquility, consider the speed of some dinosaurs. While we often picture them as lumbering giants, many dinosaurs were remarkably fast. The ornithomimids, or ostrich mimics, were built for speed with their long legs and lightweight bodies. The fastest dinosaurs could likely run at speeds of 40 to 50 miles per hour, as fast as a modern racehorse. Imagine them sprinting across ancient plains, their powerful legs carrying them swiftly across landscapes that existed when the world was unimaginably young. Rest now in this ancient world, where time itself seems to slow, where the rhythm of life beat to a different, deeper drum. Allow yourself to sink even deeper into relaxation as we continue our gentle exploration of the ancient world, where the story of life unfolded across vast expanses of time. Let us travel now to the late Cretaceous period, about 76 million years ago, to witness one of the most elaborately decorated dinosaurs ever discovered. Stegosaurus, whose name means spiked lizard, possessed one of nature's most spectacular displays. From the back of its large bony frill extended 6 long horns, each up to 2 feet in length, creating a crown-like appearance. A single horn, up to 2 feet long, projected from its nose. These dramatic features likely served multiple purposes: defending against predators, battling rivals, and perhaps most importantly, attracting mates. Just as a peacock displays its tail, Stegosaurus wore its impressive headgear as both weapon and advertisement. Now picture the forests of the Cretaceous period, and imagine a predator moving through the shadows with remarkable intelligence. Triton, which lived around 75 million years ago, had the largest brain-to-body ratio of any dinosaur, suggesting it may have been among the most intelligent. Its brain was about as large as that of a modern emu, but its body was much smaller, roughly the size of a large dog. Triton had enormous eyes that faced partially forward, giving it binocular vision and the ability to see in low light, perfect adaptations for hunting at dawn, dusk, or even at night. With its grasping hands, sharp teeth, and keen senses, Truden represents what some scientists believe might have been the path toward even greater intelligence, had dinosaurs not met their end. Here's a fascinating detail about dinosaur skin. While we often imagine dinosaurs with scales like modern reptiles, fossil evidence has revealed a much more complex picture. Many dinosaurs had skin with a pebbly or tuberculate texture, with scales of varying sizes arranged in intricate patterns. Some areas might have larger scales surrounded by smaller ones, creating beautiful geometric patterns. Impressions of dinosaur skin preserved in fine sediment show us that each species had its own unique pattern, as distinctive as fingerprints. These patterns would have helped with camouflage, temperature regulation, and perhaps even species recognition. Let yourself drift now to the shallow seas that covered much of North America during the Cretaceous period. While not technically dinosaurs, the flying pterosaurs and swimming marine reptiles shared the world with their terrestrial cousins. But there was one dinosaur that genuinely took to the water. Spinosaurus, which lived about 95 million years ago in what is now North Africa, was the largest known carnivorous dinosaur, reaching lengths of up to 50 feet. Recent discoveries have revealed that Spinosaurus had a paddle-like tail and dense bones, adaptations for swimming. It likely spent much of its time in water, hunting fish with its crocodile-like snout filled with conical teeth. Imagine this massive predator, with its distinctive sail rising from its back, gliding through ancient rivers like a prehistoric crocodile. The sail on Spinosaurus's back, formed by tall neural spines covered with skin, could reach heights of nearly 6 feet. Scientists have debated its purpose for years. It may have been used for display, to make the dinosaur appear larger to rivals or more attractive to mates. It might have helped with temperature regulation, allowing the animal to warm up quickly in the morning sun or cool down by facing away. Or perhaps it served multiple functions, as many elaborate structures in nature do. Whatever its purpose, it made Spinosaurus one of the most distinctive dinosaurs to ever exist. As you breathe slowly and deeply, consider the colors of the dinosaur world. For most of history, we could only guess at dinosaur coloration. But in recent years, scientists have discovered microscopic structures called melanosomes preserved in some feathered dinosaur fossils. These melanosomes, which contain pigment, reveal actual colors. We now know that some dinosaurs had dramatic coloring. A small dinosaur called Sinosauropteryx had a striped tail with reddish-brown and white bands, like a raccoon. Another, Microraptor, had glossy, iridescent black feathers that would have shimmered in the sunlight like a modern crow or grackle. The prehistoric world was not the drab, gray-green landscape of old paintings, but a world of color and pattern. Travel with me now to the end of the Cretaceous period, around 68 million years ago, where one of the most heavily armored dinosaurs ever to live grazed peacefully in what is now North America. Ankylosaurus was like a living tank, covered from head to tail in thick, bony plates called osteoderms. These plates were embedded in its skin and formed a nearly impenetrable armor. Even its eyelids were armored with bony shutters. But its most impressive weapon was its tail, a massive club made of fused bone that could weigh up to 60 pounds. Swung with the powerful muscles of its back and hips, this club could deliver devastating blows to any predator foolish enough to attack, potentially breaking bones even in the legs of a Tyrannosaurus rex. Finally, as you settle into complete relaxation, consider this remarkable fact: some dinosaurs lived in the Arctic. Fossils of dinosaurs have been found in northern Alaska, in areas that, even during the warmer Cretaceous period, experienced months of winter darkness. These dinosaurs, including hadrosaurs and small theropods, had to survive prolonged cold and darkness. Some may have migrated south for the winter, traveling hundreds of miles. Others likely stayed year-round, perhaps growing insulating feathers or entering periods of reduced activity. It's a reminder that dinosaurs were remarkably adaptable creatures, capable of thriving in environments from tropical forests to polar regions. Let these ancient creatures continue their slow march through your imagination as you drift deeper into peaceful rest. Breathe gently and let your mind wander through the mists of deep time, where every breath you take spans millennia, and peace settles over the ancient landscape. Let us journey now to meet one of the most iconic dinosaurs, instantly recognizable by the three magnificent horns adorning its face. Triceratops lived at the very end of the age of dinosaurs, around 68 to 66 million years ago, roaming the forests and plains of western North America. Its name means three-horned face, and those horns were formidable. The two brow horns could grow up to 3 feet long. But perhaps even more impressive was its frill, a massive bony shield extending back from its skull. This frill could measure up to 7 feet across, making Triceratops's skull one of the largest of any land animal ever to exist. Imagine these magnificent creatures, weighing up to 12 tons, moving in herds across ancient floodplains, their horns glinting in the Cretaceous sun. Now, let your thoughts drift to something truly extraordinary about dinosaur growth. Unlike mammals, which typically reach adult size and then stop growing, many dinosaurs continued to grow throughout their lives, though the rate slowed as they aged. This is called indeterminate growth. Scientists can examine dinosaur bones under microscopes and count growth rings, much like tree rings, to determine not only how old a dinosaur was when it died, but how fast it was growing at different life stages. Some large sauropods may have lived for over 100 years, slowly adding size year after year, never quite stopping their expansion toward the sky. As you sink deeper into tranquility, picture the nesting grounds of dinosaurs. In Montana, paleontologists discovered an extraordinary site called Egg Mountain, where thousands of dinosaur eggs were preserved. These weren't scattered randomly, but arranged in organized nests, often in colonies containing hundreds of nests. The eggs were carefully arranged in spiral patterns, showing that dinosaurs took great care in constructing their nests. Some species would bury their eggs in vegetation, using the heat from decomposing plants to incubate them, like some modern reptiles do. Others may have sat on their nests like birds, using their own body heat to warm their developing young. Here's something that may surprise you. Not all dinosaurs were slow-growing reptilian creatures. Some smaller dinosaurs, particularly the theropods, grew remarkably quickly. Studies of bone growth in dinosaurs like Tyrannosaurus rex reveal that they went through an explosive growth spurt during adolescence, gaining as much as 4 pounds per day during their teenage years. A young T-Rex might grow from a 50-pound hatchling to a 7-ton adult in just 20 years. This rapid growth is more similar to modern birds and mammals than to reptiles, suggesting these dinosaurs had high metabolic rates and may have been warm-blooded. Let us travel now to ancient China, to the early Cretaceous period around 125 million years ago, where one of the most perfectly preserved dinosaurs was discovered. Stegosaurus, whose name means parrot lizard due to its beak-like mouth, lived in what were once deserts and forests. But what makes Stegosaurus particularly special is that we've found specimens with their skin, scales, and even color patterns preserved. These fossils reveal something remarkable. Stegosaurus had counter shading, with darker pigmentation on its back and lighter coloring on its belly. This is the same camouflage pattern used by many modern animals, from deer to sharks, helping them blend into their environment by counteracting the effects of sunlight and shadow. As your breathing becomes slower and more rhythmic, consider the sounds of the dinosaur world. We've already mentioned the haunting calls of hadrosaurs, but dinosaurs likely produced a symphony of sounds. Some may have bellowed like alligators, others chirped like birds, and some possibly produced deep, rumbling infrasound, frequencies too low for humans to hear but capable of traveling for miles. Fossils of the dinosaur Pinacosaurus show evidence of an enlarged middle ear, suggesting it could hear these low-frequency sounds. Imagine standing in a Cretaceous forest at dawn, surrounded by an alien orchestra of roars, trumpets, chirps, and rumbles, as the dinosaur world awakened to greet another day. Travel with me now to South America, to the late Cretaceous period around 70 million years ago, where one of the most unusual predators stalked the ancient landscape. Giganotosaurus, whose name means giant southern lizard, was one of the largest carnivorous dinosaurs ever discovered, possibly even larger than Tyrannosaurus rex. It could reach lengths of up to 43 feet and weigh close to 8 tons. But here's what makes Giganotosaurus particularly intriguing. Fossil evidence suggests these massive predators may have hunted in packs. Remains of multiple individuals found together, along with bite marks on sauropod bones, hint that these giants might have cooperated to bring down prey even larger than themselves. A terrifying thought, packs of multi-ton predators working together with coordinated strategy. Finally, as you drift toward the edge of sleep, let me share one more gentle fact. Dinosaurs had lips. This might seem trivial, but it's a detail that changes how we imagine them. Recent research suggests that most dinosaurs, including fearsome predators like T-Rex, had scaly lips covering their teeth when their mouths were closed, much like modern lizards and mammals. This protected their teeth from drying out and damage. So instead of the perpetual tooth-bearing snarl we see in movies, dinosaurs would have looked more subdued when at rest, their powerful teeth hidden behind protective lips until the moment they needed them. Rest peacefully in this ancient world, where giants walked softly and time flowed like honey, thick and slow and sweet. Allow yourself to float effortlessly through the currents of time, as we continue our tranquil journey through the age when giants ruled the earth. Let us turn our attention now to one of the most curious features found in dinosaurs, the thumb spike of Iguanodon. This large herbivore lived during the early Cretaceous period, around 125 million years ago, in what is now Europe. For many years after its discovery, scientists were puzzled by a large, conical bone found with Iguanodon fossils. Some early reconstructions even placed it on the dinosaur's nose, like a horn. But we now know this was actually a thumb spike, a pointed, bony cone that replaced the thumb on each hand. This spike, which could be up to 6 inches long, likely served as a defensive weapon against predators, or perhaps as a tool for breaking into tough plant material. Imagine these peaceful giants using their thumb spikes to pry open seed pods or deliver a painful jab to an attacking predator. Now, let your mind drift to something truly massive. The longest dinosaur ever discovered is Diplodocus, a sauropod from the late Jurassic period around 150 million years ago. While not the heaviest dinosaur, Diplodocus was extraordinarily long, with some individuals reaching up to 108 feet from nose to tail tip, longer than 3 school buses placed end to end. Much of this length was tail, a magnificent whip-like structure containing up to 80 vertebrae. Scientists believed Diplodocus could crack its tail like a whip, creating a sound like a thunderclap that could startle predators or communicate with other members of its herd. The sound would have been audible for miles across the ancient plains. As you breathe slowly and deeply, consider the discovery of the first dinosaur fossils to be scientifically recognized. In 1824, British geologist William Buckland formally described Megalosaurus, making it the first dinosaur to receive a scientific name, though the word dinosaur wouldn't be coined for another 18 years. The fossils, including a massive jawbone with sharp teeth, had been discovered in Oxfordshire, England. Buckland initially thought they belonged to a giant lizard, and estimated the creature to be 40 feet long, though we now know Megalosaurus was actually closer to 20 feet. Still, this moment marked the beginning of humanity's fascination with these ancient giants, opening a door to a world we never knew existed. Let your thoughts drift now to the late Cretaceous period, around 75 million years ago, where some dinosaurs developed remarkable defensive armor. Pachycephalosaurus, whose name means thick-headed lizard, possessed a dome of solid bone on the top of its skull that could be up to 10 inches thick. For years, scientists believed these dinosaurs used their thick skulls to headbutt each other like rams, competing for mates or territory. However, more recent research suggests the dome may have been too fragile for direct impacts. Instead, these dinosaurs may have engaged in flank butting, striking each other's sides with their reinforced heads, or used their domes primarily for display, with the largest, most impressive domes winning contests without actual combat, nature's version of intimidation through impressive architecture. Here's a detail that brings dinosaurs closer to the familiar world around us. Coprolites, fossilized dinosaur droppings, have taught us an enormous amount about what dinosaurs ate and how their digestive systems worked. Some coprolites are truly massive. A T. rex coprolite discovered in Saskatchewan measures over 17 inches long and contains fragments of crushed bone, confirming that T. rex crushed and consumed the bones of its prey. Other coprolites contain seeds, showing us which plants certain dinosaurs preferred. Some even contain evidence of parasites, revealing that dinosaurs suffered from intestinal worms just like modern animals. These humble fossils provide an intimate window into the daily lives of creatures that lived millions of years ago. As you sink even deeper into relaxation, picture the late Jurassic period, around 150 million years ago, in what is now Germany. Here, preserved in the fine limestone of ancient lagoons, we find Archaeopteryx, one of the most important fossils ever discovered. Archaeopteryx represents a transitional form between non-avian dinosaurs and birds, possessing both dinosaur features, teeth, clawed fingers, and a bony tail, and bird features, wings with flight feathers and a wishbone. About the size of a modern raven, Archaeopteryx probably couldn't fly as powerfully as modern birds, but could glide and perhaps fly for short distances between trees. This remarkable creature shows us evolution in action, capturing a moment in deep time when dinosaurs were becoming something new. Travel with me now to the concept of dinosaur intelligence. While we've mentioned Truden's large brain, most dinosaurs were not particularly intelligent by modern mammal standards. However, intelligence comes in many forms. Some dinosaurs showed evidence of complex social behavior, memory, and problem-solving. Deinonychus, a raptor that lived around 115 million years ago, shows evidence in fossil trackways of hunting in coordinated groups. Its brain structure suggests well-developed senses and the ability to process complex information about its environment. At about 11 feet long and weighing around 160 pounds, Deinonychus was built for agility and cooperation, with its famous sickle-shaped claw on each foot capable of delivering devastating slashing attacks. Finally, as sleep begins to embrace you, consider the sheer abundance of dinosaurs. During their reign, dinosaurs dominated virtually every terrestrial ecosystem on Earth. Fossil evidence suggests that in some environments, dinosaur biomass, the total weight of all dinosaurs in an area, exceeded that of all other land animals combined. In the late Cretaceous forests of North America, you might have seen dozens of different dinosaur species in a single day, massive ceratopsians grazing in herds, duck-billed hadrosaurs feeding near rivers, armored ankylosaurs browsing low vegetation, small raptors darting through undergrowth, and tyrannosaurs watching from the shadows. The world belonged to them, utterly and completely, for an expanse of time so vast it defies human comprehension. Let yourself rest now in this complete and ancient world, where every creature knew its place, and time stretched endlessly forward. Breathe softly and let the prehistoric world wash over you like gentle waves, each fact a ripple in the vast ocean of time. Let us drift now to one of the most spectacular discoveries in paleontology, dinosaur fossils preserved with their last meals still inside them. In China, scientists discovered a small raptor called Sinocalliopteryx with the remains of not one, but two smaller dinosaurs in its stomach cavity. This remarkable fossil, preserved 120 million years ago, shows us that this predator had eaten two bird-like dinosaurs shortly before its death. Another fossil shows a small mammal inside a dinosaur's ribcage, but remarkably, the mammal had been eating the dinosaur, a rare glimpse of a prehistoric mammal feeding on a dinosaur, perhaps as a scavenger. These frozen moments in time reveal the complex web of predator and prey relationships that existed in the ancient world. Now, let your mind wander to the question of dinosaur lifespan. Different dinosaurs live for vastly different lengths of time. Small dinosaurs, like the chicken-sized Compsognathus, may have lived only 10 to 15 years. Medium-sized predators like Allosaurus might have reached 25 to 30 years. But the giant sauropods, those magnificent long-necked titans, could have lived for a century or more. Some estimates suggest that the largest sauropods might have lived 200 years, though reaching such ages would have been rare, as predation, disease, and accidents took their toll long before old age could. Imagine a single Brachiosaurus, standing in the same river valley for 100 years, watching generations of smaller creatures come and go, a living monument to the patience of deep time. As you relax even deeper, consider the amazing discovery of dinosaur soft tissue. In 2005, paleontologist Mary Schweitzer announced something that seemed impossible. She had found soft, stretchy blood vessels and what appeared to be red blood cells inside a 68-million-year-old Tyrannosaurus rex bone. The scientific community was initially skeptical, as conventional wisdom held that such delicate structures couldn't possibly survive for millions of years. But further research has confirmed these findings, and similar soft tissues have now been found in other dinosaur fossils. While the tissue is highly degraded and fossilized in complex ways, it offers unprecedented insights into dinosaur biology, including possible information about their proteins and even, potentially, fragments of ancient DNA, though bringing dinosaurs back to life remains firmly in the realm of science fiction. Let yourself float now to South America, to the Cretaceous period around 90 million years ago, where one of the largest flying creatures ever to exist soared through ancient skies. Though not technically a dinosaur, Quetzalcoatlus lived alongside dinosaurs and was a pterosaur, a flying reptile with a wingspan that could reach up to 36 feet, equivalent to a small airplane. Standing on the ground, it would have been as tall as a giraffe. Despite its enormous size, Quetzalcoatlus was remarkably light, with hollow bones and a body weight of only around 440 to 550 pounds. It likely spent much of its time on the ground, stalking prey like a massive stork, but was capable of true powered flight, launching itself into the air with its powerful wing muscles. Here's something that may surprise you about dinosaur evolution. The characteristic features that made dinosaurs successful, their upright posture with legs positioned directly underneath their bodies, rather than sprawling out to the sides like in lizards, appeared very early in their history. This efficient stance allowed them to move more quickly and with less energy expenditure than their reptilian relatives. Additionally, many early dinosaurs had a more efficient respiratory system, with air sacs similar to those found in modern birds, allowing for better oxygen intake. These advantages, combined with their appearance during a time when other dominant reptiles were declining, allowed dinosaurs to rapidly diversify and spread across the globe. As your breathing becomes slower and more rhythmic, picture the Antarctic landscape of 70 million years ago. Yes, Antarctica, but not the frozen wasteland we know today. During the age of dinosaurs, Antarctica was much warmer, covered in temperate forests of conifers, ferns, and flowering plants. Dinosaurs thrived there, including a species called Cryolophosaurus, whose name means frozen crested lizard. This predator, about 20 feet long, had a distinctive forward-pointing crest on its head that looked like a pompadour hairstyle. The discovery of Cryolophosaurus and other Antarctic dinosaurs reminds us that the Earth has been many different worlds, with climates and landscapes that would be unrecognizable to us today. Now, let your mind drift to one of the most heavily studied dinosaur sites in the world, the La Brea Tar Pits in Los Angeles. Wait, the tar pits are famous for mammoths and saber-toothed cats, not dinosaurs. And you're absolutely right. This is an important reminder: dinosaurs, except for birds, went extinct 66 million years ago, while the creatures trapped in the La Brea tar pits lived between 50,000 and 10,000 years ago, long after the dinosaurs were gone. The vast stretch of time that separates different prehistoric eras is difficult to grasp. Tyrannosaurus rex is actually closer in time to watching the Super Bowl than it is to Stegosaurus. The age of dinosaurs was so long that ancient dinosaurs had fossils of even more ancient dinosaurs. Finally, as you drift toward complete tranquility, consider the diversity of dinosaur diets. While we often focus on the dramatic carnivores and the enormous herbivores, dinosaurs had evolved to eat almost everything. Some, like Oviraptor, were egg-eaters, using their powerful beaks to crack open the shells. Others, like various small theropods, were insectivores, catching and eating prehistoric bugs. Some dinosaurs were omnivores, eating both plants and meat. Stomach contents of Ornithomimus show it consumed plants, small animals, and even shellfish. And some paleontologists believe certain dinosaurs may have been filter feeders, straining tiny organisms from water like modern flamingos. Every ecological niche, every food source, had its specialized dinosaur, creating ecosystems of breathtaking complexity. Rest now, letting these ancient wonders fade gently into your dreams, where time has no meaning and the past and present merge into peaceful darkness. Let yourself sink deeper still, floating through the warm currents of prehistory, where each moment is an eternity and each eternity passes in the blink of an eye. Picture now the remarkable discovery made in the Gobi Desert of Mongolia, a fossil so extraordinary it captures a moment of life and death frozen for 80 million years. In 1971, paleontologists discovered two dinosaurs locked in eternal combat, a velociraptor and a protoceratops, preserved exactly as they died. The velociraptor's sickle claw is embedded in the protoceratops's throat, while the herbivore's powerful beak has clamped down on the predator's arm. A sudden sandstorm or collapsing sand dune likely buried them both mid-battle, preserving this dramatic encounter forever. It's a snapshot of a moment that lasted only seconds, stretched across millions of years, waiting patiently in the desert sands to tell its story. Now, as you breathe slowly and peacefully, consider the size of dinosaur hearts. For the largest sauropods like Argentinosaurus, which could weigh 70 to 100 tons, scientists estimate their hearts may have weighed as much as 440 pounds and been the size of a small car. The challenge of pumping blood up those incredibly long necks, sometimes 40 feet or more, required tremendous blood pressure. Some estimates suggest sauropod blood pressure may have been 2 to 3 times higher than that of modern giraffes, which already have remarkably high blood pressure to pump blood up their long necks. These massive hearts would have beaten slowly, perhaps only 20 to 30 times per minute, each powerful contraction sending blood on its long journey through these titanic bodies. Let your mind drift now to the discovery that changed everything we thought about the end of the dinosaurs. In 1980, physicist Luis Alvarez and his geologist son Walter discovered a thin layer of clay in rocks dating to 66 million years ago. This layer, found all around the world, contained unusually high levels of iridium, an element rare on Earth but common in asteroids. This discovery led to the now accepted theory that an asteroid approximately 6 miles wide struck the Earth near what is now the Yucatan Peninsula in Mexico, creating the massive Chicxulub crater. The impact released energy equivalent to billions of atomic bombs, triggering wildfires, tsunamis, and a nuclear winter that blocked out the sun for years, ultimately ending the reign of the non-avian dinosaurs. As you relax even deeper into tranquility, consider the fascinating world of dinosaur tracks and footprints. These trace fossils, preserved in ancient mud and sand, tell stories that bones cannot. In places like the Paluxy River in Texas, we can see trackways showing how dinosaurs moved, their gait, their speed, whether they traveled alone or in groups. Some trackways show predator and prey tracks intersecting, suggesting a hunt in progress. Others show dozens of sauropod tracks all heading in the same direction, evidence of migrating herds. One remarkable site in Bolivia contains over 5,000 dinosaur footprints on a vertical cliff face. The ancient lakebed was tilted by geological forces, turning a horizontal surface into a wall. These footprints are the closest we can come to watching dinosaurs in motion. Here's a gentle thought as you drift towards sleep: dinosaurs built nests and cared for their eggs with remarkable tenderness. In Montana's Egg Mountain, scientists found fossilized nests of truden containing up to 24 eggs arranged in neat pairs, partially buried in soil. The adult would have sat in the center of the nest, their body covering the eggs like a brooding bird. Even more touching, fossil evidence shows that some dinosaurs, like the small theropod Pseudopodi, died while protecting their nests. One famous fossil shows a Pseudopodi skeleton sprawled over its nest, arms spread wide to shelter the eggs beneath, frozen in this protective posture for 75 million years. It's a gesture of parental devotion that transcends time, as recognizable and moving today as when it happened in the Cretaceous period. Travel with me now to the late Jurassic period, around 150 million years ago, where one of the most perfectly preserved dinosaur fossils was discovered in Germany. This specimen of Compsognathus, meaning elegant jaw, was so well preserved that scientists could see the remains of its last meal, a small lizard, still visible in its stomach area. Compsognathus was tiny, about the size of a modern chicken, weighing only around 7 pounds. It was one of the smallest known dinosaurs, a delicate and swift predator that darted through the undergrowth catching insects, small reptiles, and other prey. The contrast between this diminutive hunter and the massive sauropods that lived alongside it reminds us that dinosaurs came in every imaginable size. Now, let yourself float peacefully as we consider dinosaur intelligence from a different angle. While we've discussed brain size, what matters more is the brain-to-body ratio and brain structure. Many plant-eating dinosaurs had relatively small brains because they didn't need complex problem-solving abilities. their lives revolved around finding food that couldn't run away. But predators needed sharp senses, good memory, and the ability to plan and coordinate. The structure of theropod brains shows enlarged areas for vision, balance, and coordination. Some, like the raptors, had brain structures suggesting they could have been as intelligent as modern crocodiles or some birds, capable of learning, memory, and even rudimentary problem-solving. They were not the dim-witted monsters of early imagination, but alert, capable hunters finely tuned to their environment. Finally, as sleep's gentle embrace draws near, consider this beautiful detail: some dinosaurs may have sung. The hollow crests of hadrosaurs, the air sacs of various species, the syrinx-like structures found in some theropod fossils, all suggest that the Mesozoic world was filled with sound. Scientists have created computer models of hadrosaur crests and simulated the sounds they might have produced: deep, resonant calls that could have carried for miles, used to attract mates, warn of danger, or maintain contact with the herd. Imagine standing in a Cretaceous valley at dusk, listening to the songs of dinosaurs echoing off distant mountains, a prehistoric chorus that no human ear would ever hear, yet one we can almost touch through the miracles of science and imagination. Let these songs of ancient Earth lull you deeper into rest, where dreams and prehistory become one. Drift now through the deepest layers of time, where the boundary between waking and sleeping dissolves like mist in the morning sun. Let us journey to the forests of late Cretaceous Asia, around 75 million years ago, where one of the strangest dinosaurs ever discovered made its home. Deinocheirus, whose name means terrible hand, was a mystery for nearly 50 years. In 1965, paleontologists found only its arms, massive, 8-foot-long limbs ending in huge claws, unlike anything seen before. Scientists could only speculate about what creature possessed such enormous arms. Finally, in 2014, complete skeletons were discovered, revealing the full animal, a bizarre humpbacked dinosaur reaching 36 feet in length, with a duck-like bill, a sail on its back, and those massive arms. Despite its fearsome appearance, Deinocheirus was likely an omnivore, using its great claws to dig for plants and capture fish in ancient streams. Sometimes the most mysterious creatures turn out to be the gentlest. Now, as you breathe slowly and deeply, consider the phenomenon of fossilized dinosaur skin. While bones fossilize relatively easily under the right conditions, skin is far more delicate and rarely preserved. Yet in certain locations, fine-grained sediments, rapid burial sites, we find these precious impressions. The skin of most dinosaurs was covered in scales, but not like snake scales. Dinosaur scales were more like the tubercles on a Gila monster's back, small, pebbly, non-overlapping structures. Some areas had larger scales, others had smaller ones, creating intricate patterns. A beautifully preserved hadrosaur mummy found in North Dakota showed that these dinosaurs had thin skin stretched over their bodies, with barely any fat layer, giving them a lean, athletic appearance quite different from the bulky reconstructions of the past. Let yourself float gently as we consider how dinosaurs regulated their body temperature. This question, were dinosaurs warm-blooded or cold-blooded, has fascinated scientists for decades. The truth appears to be somewhere in between. Many dinosaurs likely practiced mesothermy, maintaining body temperatures higher than their surroundings but not through the constant metabolic furnace of mammals. Large dinosaurs had an advantage called gigantothermy. They were so massive that they retained heat simply due to their size, like enormous thermal batteries. A big sauropod could maintain a stable body temperature just from its bulk, warming slowly in the sun and cooling slowly at night, its size protecting it from temperature swings that would affect smaller animals. As sleep draws nearer, picture the remarkable sight of Dinosaur Provincial Park in Alberta, Canada. This location has yielded more than 50 different dinosaur species, one of the richest dinosaur fossil sites in the world. Around 75 million years ago, this area was a lush, subtropical floodplain crossed by rivers, an ideal habitat for dinosaurs. When animals died near water, they were quickly buried by river sediments, leading to exceptional preservation. Walking through this park today, you're literally walking on a graveyard of dinosaurs, where the bones of countless individuals lie waiting beneath your feet. It's estimated that millions of dinosaur fossils remain undiscovered in locations like this around the world, each one a story waiting to be told. Here's a touching detail as you drift deeper: some dinosaurs cared for their sick and injured. Fossil evidence of healed injuries shows that dinosaurs with broken bones, deep wounds, and other serious injuries survived long enough for their bones to heal, which would have required time, rest, and likely the support of their social group. One Allosaurus specimen, known as Big Al, shows evidence of numerous healed injuries throughout its skeleton, suggesting it survived many dangerous encounters. Most remarkably, some injuries would have been temporarily debilitating, making it difficult or impossible for the animal to hunt or feed itself. The fact that these dinosaurs survived suggests they may have been cared for by others, a sign of social bonds and perhaps even primitive empathy reaching back to the Jurassic period. Travel with me now to the concept of dinosaur migration. Just as modern animals migrate to follow food sources in favorable climates, many dinosaurs likely made long seasonal journeys. Trackway evidence shows large groups of sauropods all moving in the same direction, suggesting coordinated movement across vast distances. In Alaska, the discovery of hadrosaur nesting sites suggests that some dinosaurs migrated hundreds or even thousands of miles between their summer feeding grounds and the Arctic and winter refuges further south. Imagine herds of these giants undertaking epic journeys, generations following the same ancient routes year after year, their paths worn into the landscape over millions of years, highways of a lost world. Now, let your mind rest on something wonderfully strange. Some dinosaurs had the most peculiar teeth you could imagine. Nigersaurus, which lived around 110 million years ago in what is now Africa, had a mouth like a vacuum cleaner. Its skull was delicate and lightweight, with jaws that extended forward in a broad, straight line. In those jaws were packed over 500 teeth, arranged in rows and constantly being replaced, as many as 50 columns of teeth, with new ones moving forward as old ones wore down. Nigersaurus would have kept its head down, sweeping from side to side like a lawn mower, grazing on low-growing plants. It could replace each tooth every 14 days, going through thousands of teeth in its lifetime. Finally, as you surrender to sleep's embrace, consider the role of luck in the fossil record. The vast majority of dinosaurs that ever lived left no trace. An animal must die in exactly the right place, usually in or near water, where sediments can quickly cover the body, to have any chance of fossilization. Then the fossil must survive millions of years of geological processes without being destroyed. Then it must be exposed by erosion at exactly the right time. And finally, someone must find it before it weathers away. The odds are astronomically small. Every dinosaur fossil we've found represents millions that we haven't and never will. Each fossil is a miracle, a gift across time, a voice speaking from the unimaginable past. And yet, somehow, here they are, these ancient messengers, still teaching us, still amazing us, still inviting us to dream. Sleep now, peacefully, in the company of these ancient giants, knowing that their story, improbable, magnificent, and true, continues in your dreams. Let yourself sink into the deepest peace now, where the last whispers of the ancient world fade into the gentle darkness of restful sleep. As you rest, consider one final mystery of the dinosaur world, the question of their colors and patterns. We've mentioned that some fossils preserve melanosomes that reveal actual colors, but for most dinosaurs, their appearance remains unknown. However, by studying modern animals, scientists can make educated guesses. Animals that live in forests tend to have dappled patterns for camouflage among light and shadow. Animals that live in open plains often have counter shading. Social animals frequently have distinctive markings for recognition. So perhaps a herd of Triceratops displayed individual face patterns, like the varied markings on modern elephants or zebras, allowing them to recognize each other from a distance. Perhaps young dinosaurs had different coloring than adults, like many modern birds. The Mesozoic world may have been painted in colors and patterns we can barely imagine, a living canvas stretching across 165 million years. Now, breathe slowly as we reflect on the incredible diversity of dinosaur eggs. These eggs came in many shapes and sizes, from spherical to elongated, from tiny as a golf ball to massive as a basketball. The texture varied too. Some had smooth shells, others had rough, pebbly surfaces, and some had intricate patterns of ridges and bumps. In China, paleontologists discovered eggs with a beautiful blue-green color still preserved, the first time actual egg color had been found in the fossil record. This discovery, from a dinosaur called Heywania, showed that at least some dinosaurs laid colored eggs like modern birds, perhaps using color to signal health and fitness to potential mates, or maybe to help camouflage the eggs in their nests. Let your mind drift to the end of the Cretaceous period, to the last days of the dinosaurs. Life was thriving, ecosystems were complex and diverse, with hundreds of dinosaur species sharing the world. In North America, massive herds of Triceratops and Edmontosaurus roamed the plains. Tyrannosaurus rex stalked through forests. Pterosaurs soared overhead, and early mammals scurried in the underbrush. And then, in a single day 66 million years ago, everything changed. The asteroid impact occurred during what scientists believe was the Northern Hemisphere's spring or summer. In minutes, everything within 1,000 miles was obliterated. Within hours, the entire planet was affected. Within months, most large animals were gone. Only smaller creatures, able to hide underground, hibernate, or survive on limited food, made it through. The age of giants ended not with a gradual decline, but with catastrophic suddenness. As you sink deeper into tranquility, consider what survived. Alongside the small mammals that would eventually give rise to us, birds, those avian dinosaurs, made it through the extinction event. Turtles survived. Crocodiles survived. Many fish, insects, and plants endured. But every land animal larger than about 55 pounds went extinct. The survivors faced a devastated world, a dark, cold planet where food was scarce and familiar ecosystems had collapsed. Yet life persisted, and in the millions of years that followed, these survivors diversified and evolved to fill the empty niches left by the dinosaurs. The mammals, once small and nocturnal, now had their chance, eventually producing the incredible diversity we see today, including us. Here's a beautiful thought as sleep embraces you. Dinosaur fossils have been discovered on every continent on Earth, including Antarctica. This global distribution reminds us that during the Mesozoic era, the world was connected in different ways. When dinosaurs first appeared, all the continents were joined as Pangaea. As they evolved and diversified, the continents slowly drifted apart, carrying different dinosaur populations with them. This is why we find unique dinosaurs in different parts of the world. South America had its giants like Argentinosaurus, North America had its tyrannosaurs and ceratopsians, China had its feathered dinosaurs, and Africa had its long-necked sauropods with their distinctive proportions. Each continent became an evolutionary laboratory, creating its own chapter in the dinosaur story. Let yourself float peacefully as we consider the remarkable speed of dinosaur discovery. When the word dinosaur was coined in 1842, only 3 species were known. By 1900, that number had grown to a few dozen. Today, we've named over 1,000 different dinosaur species, and new ones are discovered at a rate of about 50 per year. This means that our understanding of dinosaurs is constantly evolving and expanding. Each new discovery has the potential to change everything we thought we knew. The feathered dinosaurs of China, discovered mostly in the last 30 years, completely transformed how we picture these animals. Who knows what surprises still lie buried in ancient rocks, waiting to reshape our understanding once again. Now, as you rest in complete peace, think about the legacy of dinosaurs in human culture. From the moment we discovered them, dinosaurs have captured human imagination unlike almost any other scientific discovery. They appear in our stories, our movies, our art. Children around the world can name dinosaurs before they can read. These ancient creatures spark wonder and curiosity, bridging the gap between science and imagination. They remind us that our world has a deep history, that life takes forms beyond our everyday experience, and that the universe is far stranger and more wonderful than we might think. In a way, dinosaurs connect us to the vastness of time, making millions of years feel somehow real and touchable. Finally, as you drift into the deepest sleep, consider this last gentle fact: the story of dinosaurs is not really over. Every morning, dinosaurs wake up all around the world. They sing from trees, they soar through the air, they swim in ponds and oceans. The sparrow at your window, the eagle overhead, the penguin in Antarctic waters, all are dinosaurs, carrying within them the legacy of those ancient giants. When you hear a bird's song, you're hearing an echo of the Mesozoic era, a living connection to a world that existed long before humans. The dinosaurs never truly left us. They simply changed, adapted, and flew into a new age. And in that sense, their reign never ended, it merely transformed into something new, something that still shares our world, reminding us daily that life is resilient, adaptable, and full of endless possibilities. Rest now, completely and deeply, in the peaceful knowledge that you've journeyed through 165 million years of history, through the rise and transformation of Earth's most magnificent creatures. Let the gentle weight of deep time settle over you like a warm blanket, and drift away into dreams where ancient and modern merge, where past and present are one, where sleep comes easily and peace reigns eternal. Good night, fellow traveler through time. Sleep well.